Hello guys, welcome back. So here we have another question on network theory from GATE 2017. This is again a simple question. So in the circuit shown below, the maximum power transfer to the resistor R is dash watt. So we need to find the maximum power transferred. So how we'll find that? So for that we need to find the value of R such that the maximum power is transferred to this R. So that you can use maximum power transfer theorem. So this theorem we already derived while discussing previous questions. So here I'll just state it. So let's say we are able to convert this circuit into some VTH and RTH, which is the Thevenin equivalent, and then we have this R. So the maximum power will be transferred for R is equal to RTH. And what will be the maximum power transfer? So what is I in the circuit? It is VTH by RTH plus R whole square into R. I square R is the power. And for maximum R is equal to RTH. So this VTH square by 2R whole square is 4R square into R. So it is VTH square by 4R. So now let us just try to find this RTH. Again, this R is equal to RTH, right? Okay. So let us take this circuit. We need to find VTH and RTH looking into this node. So if it is difficult for you to observe how to look into this, first let us convert this into some series parallel combination with this R. So let's say this is 5 ohm and this was 5 volts. So now it is in parallel combination. So either this R can be here or we can also put it here. It doesn't change. So now you can just find the RTH and VTH of this equivalent circuit. So let us take this. Okay. So let us first find the VTH looking into this node. So we can also assume this as ground. Let us assume some I is flowing here. So the same I will flow here. And here this 2 ampere is flowing. So here I minus 2 will flow. So let us write a KVL around this loop. So we have plus 5 minus I into 5, which is the drop. And we have plus 6 minus of 5 into I minus 2. And this is equal to 0. So 5 minus 5i plus 6 minus 5i plus 10 equal to 0. So 10i we can take to the other side. 10i is equal to 11 plus 10, 21. So I is equal to 2.1 ampere. So if I is 2.1, what will be VTH? VTH is nothing but 5 minus the IR drop, right? 5 into 2.1. So this is 5 minus 10.5. So it is minus 5.5 volts. So this is the VTH. So next let us find the RTH. So here if we have, let's remove this. So we need to short all the voltage sources and open out our current sources, right? So now we need to find the RTH here. So if you observe, it is just 5 ohm in parallel with 5 ohm. Since it is short, this 3 ohm goes away. So RTH is equal to 5 ohm in parallel with 5 ohm, which is equal to 2.5 ohm. So effectively how this circuit becomes? So it is minus 5.5 volt and it has a series resistance, right, of 2.5 ohms, and we have this R. So what does this negative sign indicate? So this negative sign actually indicates that in our original circuit, the current is actually flowing in this direction. Rather than this direction, it is actually flowing in this direction. Otherwise, there is no change. And the power transfer, anyway, it doesn't mean if it is absorbed or generated, right? So here, what will be your power max? The maximum power transfer is VTH whole square, 5.5 whole square divided by 4 into RTH, right? So if you calculate, this answer comes to be 3.025 watt. So this is your answer, 3.025. So seeing VTH being negative, you needn't be confused about it. VTH being negative indicates only the negative value of current in the arm, and it only shows the direction of current. Always remember that for a resistor, the power is always dissipated, right? Okay.